Okay, we're going to start talking about interfaces, but in order to teach this, I think it's easiest to see an example to see how they are useful. So I've written this little class called sorter, and basically all it does is it has one method that takes an array of strings, and then this will sort the array of strings. So I have this method sort these things that can be called on a sorter object. So if I open up the tester class, this is what it looks like. So again, I create a sorter object, I create an array of string with a bunch of colors in it, I tell the sorter object to sort these strings, and then I print them out. And now let's run the tester, and sure enough, look at that, all the colors come out perfectly sorted. How does the string know how to sort itself? It sorts itself with this method here called the compare to method. Okay, this is one string in the array, this is another string in the array. If this one comes before this one in their lexicographical order, according to the ASCII code table, then the result will be a negative number. Remember, we think of the compare to method as like a minus sign. So if I have A minus B, the result will be negative because that's like 1 minus 2. Similarly, if this is like a B and this is an A, the result will be positive. So again, we use compare to, and we use a negative number to indicate that the left item comes before the right item. Doing this, we see that the compare to method is really great for sorting strings. But I've put all this time into writing a sorter class, and all I can do are sort strings. If I want to sort something else, I have to go write a whole new method. For example, I'd have to copy this, paste it, and then say, well, what if I wanted to sort an array of integers? And it would have integers, so I'd have a whole integer array. And you'd have to come in here and change all the references to strings into integers, and it would be a massive pain, and it's incredibly redundant, right? I mean, it's essentially the same method. And notice that I cannot take advantage of inheritance. Integers and strings don't have a common superclass other than object, and objects can't be compared. There's no compare to method for objects because one is not necessarily greater than any other. So we have this problem where a lot of times there are classes that do not have very much in common, but they have a little bit in common, but we only need to group them together according to that small commonality. In this case, strings are similar to integers in that they both have a compare to method. They are both comparable objects. So it would be great if we could group these together, not using inheritance, but using some other mechanism, so that I could only write one of these methods. And it turns out that, of course, so I'm teaching it, you can do that using this little thing called interfaces. So what happens is there's this thing called the comparable interface, and all I have to do is rather than create an array of strings, I create an array of what we call comparables. For right now, you can think of it as a superclass, but it is not a superclass. Basically, comparable is a categorization of things that have a compare to method. So in order to be comparable, the thing must have a compare to method. So strings are comparable because they have a compare to method. Integers are comparable because they have a compare to method. And so anything that has one of these can be called comparable. And I'll talk about how that works later. There's a mechanism you have to put in place, but it's not that hard. So down here I have to remove my references to strings and call them references to comparable. Oh, it's not in there, my bad. So I'll delete all that. Good, so now notice that there are no references to strings at all. There are no references to integers at all. This code only references comparable objects. So anything that is comparable can work with this method, and I don't have to repeat my code over and over and over again. Let's go test it out. Here I have the test sorter. And what I'm going to do is create an array of integer objects. Oh, that's right. I should go back and actually change the name of this. Since we're not sorting strings anymore, we're sorting comparable items. We should just say sort these things, right? Or sort these comparable things. And that should help. But that means I have to change the things reference here. And I've just written this code while on pause. And we're going to try to sort them. And then print them out. And look at that, no compiler errors. What a masterful job by me. All right. And so now let's go test it. We're going to right click on our tester, and sure enough, all the colors are still sorted because strings are comparable, and all of the integers are sorted because integers are comparable. So that class is treating both of these in a similar way, and it's because strings are comparable, integers are comparable, and that method can work with both, with anything that is comparable, strings or integers, which prevents me from having to copy and paste my work over and over and over again. The sort these things method will work on anything that is comparable. And again, in order to be comparable, the only thing that the class needs is a compare to method. That's it. And this code will work on anything that has a compare to method. So the upshot of all this is that comparable is an interface. And an interface allows you to broadly categorize these otherwise different objects based upon the common methods that they have. So let's take a look at the comparable interface. If you go into the Java documentation, you'll see that comparable is an interface. I'll tell you about these angle brackets later. Don't worry about it right now. We'll get to that. Here's a detailed explanation. We're not going to worry about that right now, but notice the method summary for comparable is simply to have a compare to method, and it compares this object with the specified object in that order, and then they give you all kinds of detail about what has to be true for compare to, and we will get into that later as well. But the actual code, now if I say Java comparable source code, I'm going to go here. Don't worry about why, but there are lots of comments, imports, lots of comments. We can read these later. Notice what we're saying is, it says public interface comparable. We don't use the word class. So an interface is not a class. It's something different. It's a different kind of entity. And what is the definition of comparable? Comment, comment, comment. Look at this. It's one method, public int compare to, I'll explain this later, semicolon. So we don't even define what the method does. We don't write any code for this method. We clearly explain very clearly what must be true when this method executes, but the whole interface is nothing but the statement that one method exists with no actual implementation. The idea here is that an interface states what behavior its objects must have and talks about how that behavior should be implemented, but it doesn't actually implement it. And this makes a lot of sense. Think about it. In order for a string to be comparable, it must have a compare to method well defined. We can choose the specifics of how it gets defined. Similarly, an integer object, in order for it to be comparable, it must have a compare to method, but the specifics of how it gets implemented can be chosen by the class itself. So we can now go apply the comparable interface to any class that we want, as long as we also provide a well-defined compare to method. So let's go do that. Let's go to our complex number. So I've added our complex number lab from way back at the beginning of the year into this project. And what I'm going to do is, let's say that we want to declare complex numbers comparable. Now there's some mathematical problems here because truly it's very difficult to say whether one complex number is greater than or less than another because it has two components that are really somewhat different. So in other words, is 3 plus 4i greater than or less than 4 plus 3i? It's not mathematically clear how to do this, but there's this thing called lexicographical order, and so we can kind of define how we want complex numbers ordered. But the idea is, in order to say that a complex number is comparable, we must say that it implements, Java keyword, the comparable interface. And then the little trick is with the angle brackets, you always put the name of the class that you are comparing in the angle brackets. Again, I'll get into more detail why later, but for now you say it implements the comparable interface, and the idea is we are comparing to other complex numbers. Now, if I try to compile, it barks at me. It says complex number is not abstract and does not override abstract method compare to in java.lang comparable. Don't worry so much about the word abstract, but notice what they're saying is, hey, you need a compare to method. That's what they're saying. You're not allowed to state that you are comparable unless you have a compare to method. So let's go down here and write one. Just jump down to the bottom of the class. Oh, not static. Public int compare to, and the idea is we want to compare to other complex number objects. And we're going to just kind of arbitrarily say that the real number part of a complex number is the primary way that we compare these things. Now you'll see that if I code the method compare to for complex number like this, by subtracting the real parts, I have a problem because the result is a real number. And if I try to cast the result as an integer, I have a problem because then I get this inaccurate rounding, right? It'll treat, or I should say truncate 0.5 down to 0, which is not what we want. So we have to make sure that we return an integer value. So sometimes when we do compare to methods, if it depends upon real numbers, we have to do something a little more explicit. So I might want to say if this dot get real part is explicitly less than, then return, you know, a nice straightforward integer, else if greater than explicitly will return a positive number. Again, remember, it doesn't matter what positive or negative number you return as long as it's positive or negative. That's the only thing that compare to worries about. And then else if, so at this point, if these two are not greater than or equal, it means they're exactly identical, and so now it's time to compare the imaginary parts to one another. We should return -1. Again, this is only true if the real parts are identical. And same thing, else if we should return a positive number. And in any other case, would have to mean that the real parts of both are identical and the imaginary parts of both are identical, and so we're going to return 0. And there we have compare to method. We were able to say that the complex number class implements the comparable interface simply because it has a compare to method. The presence of a compare to method was enough for us to categorize all complex number objects as comparable. This is a huge step forward for us. So now we should be able to plug complex numbers into our sorter class, right? Because the sorter class method, sort these things, takes anything that is comparable. So let's go test it. Let's go into the sorter tester. Okay, so I put it on pause and I wrote this little tester code for the complex numbers. It's basically the same as the integer tester that we'd written up here, where we created an array of integers, created some random ones, sorted them, and then printed them up. Here I'm creating an array of complex numbers. I'm filling that array with 10 complex numbers with random real parts and random imaginary parts. Of course, these are integers from 0 to 9, and these are going to be integers from 0 to 9 as well. I then notice I'm calling the sort these things method on my array of complex numbers, and it's going to be sorted well because complex numbers are now comparable. So the interface is working as we want. And we're going to loop through each of them afterwards and print them all up. And so I say right click on my sorter tester, click it, and sure enough, this is the output window that shows up. So we can see the colors are sorted because the strings are comparable, the integers are sorted because the integers are comparable, and then even the complex number objects that are getting printed up, the things that we made in class, are comparable, and so they're being sorted. Again, notice that they're sorted primarily by the real part of the imaginary number, and secondarily by the imaginary part. You see these three all have a 5, and so they are sorted secondarily by the imaginary coefficient. These three all have 8s, and they're sorted secondarily by the imaginary coefficient. So the compare to method is working well, but most importantly, again, the most important part is that we only had to write one method that can sort anything, strings, integers, or complex numbers, all because of the interface. This is what allows us to interact with many, many different kinds of objects as long as they all have one common behavior. So interfaces are very powerful for saving work and making sure you don't have to repeat yourself over and over and over again.